Good morning, everyone. Nice to see so many of you online now. So, hope you had a good weekend. Just give you a few moments to get yourself a pen, paper, and calculator as usual, and we'll be off on another workout. This week, going to be looking at doing exam questions. Okay, last week we were doing topics, this week exam questions, and today it will be pure maths. Okay, it's mainly A level rather than AS today. I'll try to do a mixture of questions during the week in another pure maths session, but I'd like to think that even if you're doing AS, you should be able to get something out of these particular maths workouts. Okay, so what are we going to be doing then today? Will it be binomial expansion? I'll give you some formulas that you can work with. I mean, as mathematicians, you should also be able to just see a formula and substitute values in. That's half the battle as well. So hopefully it will give you an opportunity for that. There'll be questions along the way as well. Some of these are quite long questions, so I'll get to break them up a bit for you. Okay. Nice to see Michael on as usual. Michael from Air Maths Tuition. Many of you guys, I'm sure, have had his help before on the live chat. So welcome, Michael. And anything else? Yeah. We better get started. Okay, about 30 minutes, and hope you enjoy this. Okay, so here we go. All right, let's just bring up the first question. And this first one, it's about the binomial expansion. Okay, so we've got f of x then equals all of 3 minus 2x to the power negative 4. This could have been 1 over 3 minus 2x to the power 4. You've got to use the binomial expansion, find the binomial expansion of f of x in ascending powers of x up to and including the term in x squared, giving each coefficient as a simplified fraction. So what I'm going to ask you to do is just tell us what the coefficient of x squared is when you get there. Hopefully you'll write out all the coefficients, but rather than type them all in, just let us know when you've got the coefficient of x squared. Give it as an exact fraction, okay? So away you go, if you haven't started that one already. I'll bring up the formula for any of you guys out there who don't know what it is. I'll bring that up in a few moments, okay? But just see how you start to get on with this. This formula, by the way, is in the formula book when I display it. So in many ways, if it is in the formula book, maybe I should display it now for you, okay? I've written it as 1 plus a to the power n. You'll see it as 1 plus x to the power n. I purposely write a there, as I'll explain later on, okay? So it's identical to this, all right? So I hope you can see that. Questions I've selected for you this morning are, as I say, A-level questions from past papers. So I should be doing some AS mixed with some A-level this coming Wednesday. So hope you'll join me for that one. I can see some of you are asking that on the live chat at the moment. Okay, we have Din coming in with an answer. As usual, does anybody else have any answers? We've got some other answers coming from Rahima. Rahima seems to be giving me all coefficients, I think, here. Good to see the effort that you guys are making out there. Let's just hold on just a little bit longer and see what other answers come through. Okay. Again, still good to see that you're taking part in this, having a go. Okay, well, yep, answers coming through, I can see now. There might be a bit of a delay here as I see the answers. You get to hear what I say. Good, okay. Good effort from a lot of you guys. Interesting to see that we've got as the coefficient of x squared from some of you, 20 over 243. I'm just trying to think how you might have got that, but the actual answer is 40 over 729. So well done. I see that Din was the first in there with that answer. Well done. Congratulations, Din. And Nick coming in also with 40 over 729, as well as Gary there. Okay, so let's just quickly run through this. Raja, sorry, I missed you out. I can see that you had 40 over 729. Great stuff, guys. Okay, well, let's just quickly run through this. When you get questions like this, the key to it is that you pull out the 3 first of all from the from the 3 minus 2x, so that you can make this a 1. So you pull the 3 out, and then you're going to have 1 minus 2/3 x to give you the 3 minus 2x, and it's all to the power minus 4. And then what you need to do is that power minus 4 goes over the 3 and over the bracket. 3 to the minus 4 is 1 over 3 to the power 4, which is 1 over 81. You're going to need that later on. And you're now going to substitute the a as minus 2/3 x. I did say that in the formula book, you'll often see it as written as 1 plus x to the power n. I prefer just to write it as, or think of it as a. You can see the a becomes the minus 2/3 x. Okay, so you just got to substitute this in here. 1 plus n, the power, minus 4, times a, minus 2/3 x. It's over factorial 1, but factorial 1 is just 1, okay? So I've left that out. N minus 4 times n minus 1, so subtract 1 from that power. Over 2 factorial, 2 times 1 in other words, times what was a squared is now minus 2/3 x all squared, plus and so on. So just work this out. Don't trip up, hopefully, on the signs, okay? And that is your answer. Okay, I'm just wondering whether some of you guys did square that -2 out there, okay, to give you a 4, all right, when I see the answers 40 over, sorry, when I see the other answers that you guys gave us, okay. So just check you're working on that. Hopefully you'll get to grips with that. Okay, so well done then to any of you who got that. Okay, we're moving swiftly on to, oh, I know what I wanted to say to you. Just out of interest, okay, let's just put this up. When you're working out questions like this, when n is not an integer, it's very common to be asked, what is the range of values of x for which this is valid for? And in fact, it's this. This is why they've got this here. And I'll just remind you on that, just in case you get a question on that. They're bound to appear. When it comes to what we call validity, let me just write this in here, validity. Okay. When you're asked for the validity of the binomial expansion, your a term has to lie between -1 and 1. And the a term in this was minus 2/3 x. So you've got minus 2/3 x, okay, has got to lie between -1 and 1. And then if you multiply both sides throughout by 3, you're going to get -3 is less than -2x is less than 3. And then you could divide throughout by -2. And when you do that, remember you've got to turn the inequalities round when you divide by a negative value. So this is going to be 3/2 is greater than, okay, x, which in turn is greater than -3/2. And then that doesn't look good. You best change this all the way around so that you're working in ascending values. So x has to lie between -3/2 and 3/2. Okay? And that is the same as writing this statement here. So just to remind you about the validity of a binomial expansion when n is not a positive integer. Okay? So there we go. Let's move on then, okay, to the next question. Question 2a. Now, you've got to know your trig identities here. Show that cot squared x minus cosec x minus 11 equals 0 may be expressed in this form. Cosec squared x minus cosec x plus k, a constant k, equals 0. So all I want to know is what is that constant k. So just enter that, okay, when you're done. What's the constant k? So, got to know your identities. It's quite a short question. It's a 1 marker, so shouldn't take too long. Right, Alfred coming in with a value for k. Anybody else out there? Okay, we've got a few more coming in. Okay, good stuff, good stuff. Okay. Right, this is a fairly straightforward one once you know the identity. Let's just copy down the question first of all. What is that identity? Okay, you can see that we've got to get this transferred to a quadratic equation in cosec x. And you should be aware of this particular identity. Okay, 1 plus cot squared x is identical to cosec squared x. So all you need to do, okay, is just rearrange this. Cot squared x is identical to cosec squared x minus 1, and just substitute it in here. And that's what I've done. Okay, so when you simplify this, minus 1 minus 11, you're going to get minus 12. So that constant k is going to be minus 12. Nice easy one there. Okay, well this was part A anyway of this question. So obviously there was another part, and that's what we're going to be moving on to next. So this is the next part. Hence solve for x greater than or equal to 0 but less than 360 degrees. This equation, cot squared x minus cosec x minus 11 equals 0. And give each solution in degrees to 1 decimal place for 5 marks. And your solutions are based entirely on graphical or numerical methods are not acceptable. So you've got to have some kind of work here, okay? And this could be quite a long question, so let's just give you a few questions on the way, okay? Let's say we're going to say let's stop it when you say what the sine x values are, okay? Tell us what sine x equals. That will be a little way into this, okay? Bit of a clue there. What are the values for sine x? Okay, Your Majesty. Nice to have you here. Okay. Yes, all lessons are free. I'm just happy to do it. So if you do fancy giving any support by any chance to keep this project going, it's always welcomed. Okay. Thank you anyway for that comment. Okay. Right, okay, we've got some answers coming in. I was looking for sin x for just a bit of help for some of you. I can see Gary's come in with 2 values for sin x, and Din's come in with some. Okay, yes, you are both right. You should have at this point sin x is a quarter or minus a third. Okay, so if you want to carry on with that, okay, it'd be good. Just as a keep you on track, okay, sin x is a quarter or minus a third. I'm looking now for what is the largest angle. If you get to solve this, okay, what is the largest angle? Give it to 1 decimal place. It'll help if you can just put that up, okay? What is the largest angle? If you're stuck and you're an AS level student, pick it up where we have sin x equals a quarter or minus a third, okay? I will run through this shortly, but you should be able to pick it up from there if you're an AS student. I'm looking for the largest angle. There's quite a few solutions, but write them all down, yeah? But just enter the largest angle that you think it is. I see Your Majesty has come in with 50.2. I've been watching The Crown. I don't know if any of you watch The Crown on Netflix. I've been watching The Crown just recently, and I feel like I'm watching that when I keep saying Your Majesty. Okay, so right. Okay, let's see. We're getting a few answers coming through here for that largest angle. Okay, interesting ones, differing a bit. Okay, I can see some of you got it right. Okay. Okay, let's go for it. Okay, that largest angle, okay, is, wait for it, 340.5 degrees. Okay, well done, guys, who got that one. Looking quickly down here, I think I'm right. Is it Din? No, Rahima got 340.5. I think she was first out the box there. Okay, well done to you all, though, for taking part on that one and getting it. Okay, let's just quickly run through all solutions, though, now. Okay, so let's just move this up, okay? So, what I've done is taken part A, okay, of this question. And what we need to do now is we see this as a quadratic equation and we can factorize it. There you go. Cosec x minus 4 times cosec x plus 3 equals 0, okay? Put each factor equal to 0, and that leads to cosec x equaling 4, cosec x equaling minus 3. For you guys out there who are doing AS level, cosec is the same as 1 over sine, okay? So we end up with 1 over sine x equaling 4, or 1 over sine x equaling negative 3. So you can rearrange these for sine x, and you're going to get sine x equaling a quarter, or sine x equaling minus a third. And then if you take the inverse sine of each of these, okay, we should start to see some solutions coming through. Got to make sure, though, your calculator is in degrees mode. Always check that. Some questions are going to be in radians mode. This is clearly saying in degrees mode. Okay, so let's take, we'll number these, okay, 1 and 2, and make it easier with the space that I've got here. And we're going to look at number 1. I tend to work out solutions by the quadrant method. That's up to you. I find it a lot easier, quicker than drawing a graph, okay? So if you're familiar with the quadrant method, sine is positive in the first quadrant and the second quadrant. So I draw two lines equally inclined to the horizontal here. Mark those two angles in as being exactly the same. We're wanting these angles. This one here, which I've marked in red, and this one starting from 0 here, by the way, going round in an anti-clockwise sense to this line here. Two angles that we're going to find. Okay, so if we do the inverse sine of a quarter on your calculator, it will come up with 14.477 and so on, and that is that red angle X there, that acute angle. And to get the green one here, all I've got to do is do 180 degrees minus this answer here, okay? Because these two angles are exactly the same. If you do that, you're going to get 165.522 and so on degrees. We'll round these up at the end. Okay, so that's from 1. Now we look to 2, okay? And if we draw a quadrant diagram again, we're dealing with a negative value for sine. Sine is negative in the third and fourth quadrants. So again, draw two lines in those quadrants equally inclined to the horizontal here. So I've marked those two angles as being equal. So the values of x that we're going to want from 0 to 360 are going to be these two. The red one round to there and the green one all the way round to there. Now, when you do the inverse sine of negative a third, you're going to end up with a negative angle. I know that before I even press the calculator, purely because the calculator is programmed to give you the smallest angle in magnitude, that is, to our starting value here, 0 degrees. And this is clearly much smaller, this angle in here, than the red angle or the green angle. So it's going to give us a turn in this direction, a negative value, as you'll see. Okay, so it helps to be prepared for that. It means that you have a better understanding. In this case, it turns out to be minus 19.471, turning in that direction. Okay, so the magnitude of it is 19.471, and therefore we can get the red X by doing 180 degrees plus 19.471. And if you do that, you're going to get 199.471 and so on degrees. And for the green one, you can do 360 degrees minus this angle, okay? And that will give you 340.528 and so on degrees. Don't forget though, you had to give each solution correct to one decimal place. So summarizing, there they are. X is 14.5 degrees, 165.5 degrees, 199.5 degrees, and 340.5 degrees. Each of these are all given to one decimal place. Okay? So, hope you're able to get that one. I didn't check out all of your comments there on the live chat as I was going through this, but well done, okay, to you all for doing that. Okay, we're on the last one now. Okay, now this is a really, well, quite lengthy one. It's got quite a few interesting bits in it, okay. I like it as a question, and it's got a subtle ending to it as well. Okay, so I'll bring it up and we'll do it in stages as well, just to guide you through. Okay, so we've got here a curve C has this equation, 3 to the power x plus 6y equals 3 over 2 times xy squared. And you've got to find the exact value of dy by dx at the point C on the curve with coordinates 2, 3. Okay, x is 2, y is 3. Give your answer in this form, okay? A plus natural log of b all divided by 8, where a and b are integers, okay? Worth 7 marks. So there's quite a few steps here, okay? And away you go, all right? Now what I'd like you to do though is to say when you're done, okay, on the differential bit, okay, so that we can guide you all through the steps, okay. It'd be good to see who's first, okay. Just say done when you feel that you have differentiated this correctly, okay. So just done. Some of you guys might not know what the differential of 3 to the power x is. It's not in the formula book, okay, but I will show you it here, okay. If you were to differentiate a to the power x, it's equal to a to the power x natural log of a, okay. So that should help you through differentiating this one, okay. Just in case you haven't covered it at school at the moment or whatever, okay. There it is there. Quite a few rules that you're going to need here, okay, in order to differentiate this. This is A level, just in case you're joining us later on in this. It's not AS, okay, but I'd like to think that you could get some value from this nonetheless, especially towards the end when we end up trying to prove this result here, okay. So let's go for it. Okay, right, Amy says she's done on the differentiation part. Let's just wait for a few more people to come in. Just say they're done, and then you can you might still want to carry on, obviously, but I will just give you a little bit of working out so that you're not wasting too much time. Okay, Nick's coming in with done. Well done. Okay. Let's take a few more. All right, good stuff. Okay, I can see that quite a few have gone. You have gone for it. Okay, let's just take you through this stage in case there were any problems for any of you. We've got to differentiate with respect to x. Okay, this is implicit differentiation in stages, and it also involves the product rule. Okay, right. So differentiating with respect to x, this first term here. 3 to the power x. You can see a is the constant 3. So you're going to get 3 to the power x natural log of 3, which I've written down here. Now, when it comes to differentiating 6y with respect to x, you differentiate 6y with respect to x, first of all. It becomes 6. And then you multiply by dy by dx. It's based on the chain rule. It's called implicit differentiation. If you're unsure of that, do go on my website. Check out the video tutorials on that. I haven't put a link in the description. If you're looking on YouTube, I will do that when the video is processed. Okay, links to implicit differentiation. Next we come on to differentiating this part here. This is a combination of the product rule and implicit differentiation. I've taken the constant out the front of the square brackets. We don't need to worry about that. We're just going to differentiate the x times y squared. So it's the product rule. You take one part, let's say the x, and the other part is y squared. I know a lot of you might think of it as u's and v's. I just think of it as parts, okay? We take one part, x, and we multiply it by the differential of the other part. Differentiate y squared with respect to x, it's implicit differentiation. You differentiate y squared with respect to y and you get 2y, and you multiply it by dy by dx, okay? So that's the first part of the quotient rule. We took one part, x, multiplied it by the differential of the other part, y squared, with respect to x, and it's that, 2y dy dx, okay? Then it's plus, we take the other part, y squared, and we now multiply it by the differential of the first part, x, which is 1. Okay? So, that is basically it. When you differentiate it, you might have cleaned it up further, and if you do clean it up further, expand it out, you're going to get that. So by now, you should be on your way to trying to substitute these values in to get your answer for dy by dx in this form. Okay, so let us know if you're still out there working away at this, those values for a and b. All right, or even just give us a, give us b separately. It'd be good to see what you make for a and b. Okay. As I say, I think you've got to think a little bit about the ending here. Just a little over half an hour on this workout. Okay, this is the last question, by the way, if you are joining us. Okay. How's it going out there? Interesting to know if you think it's difficult. This was the third question in on an exam paper, so it could be a bit scary for some. Yeah, Rahima, I can see it's an interesting ending. You might well have it, but it's just trying to get it into that form. Okay, Maggie says she's done. Good. Okay, we're looking for, okay, we have John coming in with a value for B at -12. Interesting. Does anybody else agree with that? Okay, Gary thinks he's done. Right, Kieran coming in with A is -9, B is 729. Anybody else out there? Do you agree? It is quite a tricky one, the ending, as I said. Okay, time's getting on, and I want to keep this fairly short. Okay. Right. Okay, we're going to go through this. Let me know how you got on. Okay. Rahima coming in with A is -9, B is 729. Well, guys, yeah, that is the answer. Well done if you got that. Okay, A is -9, B is 729. Congratulations to you guys there. Okay, let's just show you how we go about it. Okay, substitute your values in when x is 2, y is 3. Okay, if you sub your values in, you should get this line. Okay, from here. I think that's fairly easy. Okay. Now, we just need to rearrange it. What I've done is I have taken 6 dy dx from the 18 dy dx to leave me with the 12 dy dx, and taken 27/2 from both sides to give me this. Okay? Right. Then what am I going to do? I don't like this 2 here. Okay, we don't seem to have what we're not wanting fractions in our answer. It says here we're aiming for integers, so I'm going to get rid of that 2. Multiply through by 2 and you'll get 18 here. This will be the 27 and this will go to 24. Okay, and then you want to divide by 24 to get yourself on track for dy dx. Now when you get here, you might be thinking, it's not looking quite like this at the moment. We want an 8 there. Well, to get an 8 there, you're obviously going to need to divide through by 3, top and bottom. This will make 3's into 24 go to 8. So if I look at that, divide through, I get this result. But then we got this 6, okay, in the front of the natural log of b. And at this point, you should be thinking of using the power rule. Remember, that's where you bring the 6 up on that 3. Okay, the power rule for logs. And if you do that, you're going to get -9 plus the natural log of 3 to the power 6 over 8. So b will turn out to be the 729. A is -9. Okay, so well done everyone who managed to get that. And hopefully you're able to see your way through this anyway, now that you've seen the solution. Okay? Right. Well, as usual, I'll just bring myself back on. And I hope you got some value out of that, enjoyed it, even though it might have been a bit tricky at times. Good to see you taking part, a lot of you taking part, coming back. And thank you to Michael once again for being on board, helping to answer all the your comments I can see displayed here. And yeah, so tomorrow I'm going to be doing some mechanics, okay, exam questions on mechanics, similar kind of procedure. On Wednesday we're back to pure maths. I'll put a mix of AS and A-level questions in. Don't be put off though if you're an AS person and I'm setting some A-level ones. I'm sure you'll get some value hopefully from that. Thursday is statistics, exam questions. Friday is pure maths, okay, again. So, hope you have a good day and hopefully see you tomorrow. Stay safe. Bye for now.